Okay, we're looking at mixed exercise 11 from the first year textbooks. This is on vectors. And we're starting question 1. We've got an exam question, so we can see how many marks each part is worth. Okay, so I'm given two forces. I don't have to sketch them out, but let's just clarify what's going on here. So I've got force 1 is -3, so that's going to go 3 to the right and 7 up. Let's just move that up a little bit. Hide that. So that would be F subscript 1, and then force 2 is going 1 to the right and 1 down. So that would be force 2. So the resultant of those two, so I'm sketching a little bit messy, but is going to be that vector there. So going along force 1 and then along force 2. Okay, but we don't really need to worry about that for a nice simple question like this. So R is F1. I'm going to write them as column vectors. You don't have to, it's just I find it a little bit quicker. So -3i plus 7j becomes -3, 7 as a column vector. Plus force 2, so I minus j. So the resultant force is just going to be -2 and 6. And that's going to be in newtons. But just be ever so careful. It says magnitude. So actually that would probably only get me 1 mark so far, because the magnitude of R, I just need to use Pythagoras. So obviously it's -2 all squared. So if I didn't have the minus there, that would be fine. So all I'm saying here is, so vector R, force R is -2. So that's going to be 2 to the left and 6. Let's pull that up a little bit. So that's what vector R would look like. And the magnitude of that, obviously, well, that's a right angle triangle. So obviously R is the hypotenuse of a right angle triangle. So I'm just using Pythagoras. So that is going to be √40. Double check if it mentions exact form or anything. It doesn't. So I could leave that as √40. I could simplify it as a third, or I could stick it into my calculator and get it to 3 significant figures, which would give me 6.32 newtons. Okay, and then calculate to the nearest degree the angle between the line of action of R and the vector I. Okay, so I definitely want my sketch for this. So what they're asking for, so that's vector R, and they want the angle, so the line of action, so that's going up and to the left there. Vector I goes off in that direction, so that's the angle they want. Okay, so I think the easiest way to get that would be to get, oh, I meant to change colour, never mind, would be to get that angle there, and then obviously if I take that angle away from 180, I'll be left with theta, which is the one they want. So to find alpha, well, so it's just a right angle triangle, isn't it? And I've got opposite and adjacent. So tan alpha is opposite over adjacent, and it's the magnitude I'm looking at, so I don't care about the -2. So alpha is going to be inverse tan of 6/2. So alpha is 71.6 degrees. So theta, which is the angle between R and the I vector, is therefore going to be 180 minus that. So my final answer is going to be 108.4 degrees. Okay, so we'll just quickly check those answers. Oh, hang on, maybe I should read the question carefully. So that's not the angle they wanted. All right, okay. So always worth double checking. So the angle between the line of action of R and the vector J. Okay, so let's go back and try again. So in fact, let's sketch out what they actually asked for. Right, so There's, well, in fact, I feel I can just add it to this diagram, can't I? So that's vector J. So again, actually, I do need to be careful here because it's not, so let's call that angle beta, it's not that angle they want. If I just draw a slightly nicer diagram of all this. So R is going off in that direction. Vector J, let's move that R out of the way. So that's vector R. Vector J is that direction there, so it's actually that angle they want. So in fact, I can get it from my previous answer if I just fill everything else in. So it was, let's do a different colour. So vector R was 2 to the left and 6 up. So I've got that angle there. So that was what I was calling it alpha. So I've got that angle there, but that's the J, the direction of the J vector. So it's actually that angle there I want. So it's not 180 minus 71.6, it's 90 minus 71.6. So is that going to be 18.4? Okay, so now I've actually read the question properly. Let's double check. Yep, they rounded to two significant figures and they've left the magnitude of R in exact form, but that's absolutely fine. We got the equivalent answers.